Conservation Partnership Wetland Restoration Planning and Design Overview. Like Amy said, this is a two-part training opportunity that arose from your responses to the annual ICP training inventory. Wetland restoration ranked in the top 10 topics that member employees wanted more information on. So over these two sessions, we plan to provide you with the basic information you're going to need to talk to landowners about wetlands, and then the data and steps needed to plan, design, and implement wetland restoration. Our presenters today are all USDA NRCS employees with extensive experience in wetland restoration from the perspective of our disciplines. Our different perspectives provide a holistic approach to the feasibility of wetland restoration and landowner objectives. Throughout the presentation, as I said, please feel free to enter questions in the chat. Also feel free to reach out to us anytime you may have questions after the presentation. And our emails are up there. Most of you know how to find us, I'm sure, but we'll also put this slide up at other times. So before we dive into the actual meat of the program, we must first establish what is wetland restoration. These terms you see here are sometimes used interchangeably in conversation, particularly with landowners that may not be familiar with our terminology. How many times have you had someone come into the office and ask about wanting one of those duck ponds, but really meant a wetland? Or maybe it was the other way around. Before we can begin to think about planning design, we need to establish what it is we are talking about. As a side note, for those who may not be familiar, the numbers in parentheses are the NRCS practice code numbers for reference purposes. Wetland restoration is the return of a wetland and its functions to a close approximation of its original condition prior to disturbance. It is the return to as close to what was historical as we can get. It often requires the destruction of man-made impacts to the wetland, such as the removal of drainage systems, the ceasing of agriculture, and the revegetating of the site. In this image, you can see a wet, overgrown agricultural field. The site was difficult to farm due to hydrologic conditions. The image below, as you can see from the date, is 2014. After 2 years, in a restoration of those hydrologic conditions, you can see that the hydrology and vegetation have returned to this area. On the other hand is wetland enhancement. This is the augmentation of wetland functions beyond the original natural conditions on a former, degraded, or naturally functioning wetland site. In truth, much of what we do in Indiana is a combination of these two. We are often enhancing a wetland beyond its original conditions for a number of reasons. Sometimes this is to fulfill the landowner's objectives. Sometimes this is because a particular wetland type is not present in the landscape, so incorporating more diverse habitats in conjunction with a restoration is beneficial. Enhancement could include not only engineering type activities, but it could also include different vegetative cover types. Wetland creation is the design and construction of a wetland on a site that was historically non-wetland. From an ecological perspective, this is not necessarily desirable, as it requires a tremendous effort, intensive management, and counter to what the ecosystem would naturally support. However, in areas where surface water or wetland conditions are missing from the landscape, this may be a suitable practice. I also listed constructed wetland here, but for the purposes of this wetland and from an NRCS approach, this is a water treatment wetland and does not really function for ecological purposes. This type of wetland is unique and will not be covered in these two sessions. So now that we've established what we are talking about when we're talking about wetland restoration versus enhancement, let's talk about landowner expectations. How many of you have had a landowner walk in with a stack of Ducks Unlimited magazines? A couple of photos from National Geographic. I mean, this looks like Indiana, right? Or they come in after they've been out on an Indiana wetland and have experienced for themselves the awesomeness of a flock of snow geese taking off. None of these sources of inspiration are inherently wrong or bad, but their feasibility is questionable. National organizations and magazines share stories from around the nation, and a wetland that occurs in Texas or Arkansas or Louisiana is not feasible here. Even a local wetland such as Goose Pond is only feasible because of its specific soil types, topography, and scale. These combinations do not just exist anywhere. They are very specific. So as we are talking with landowners, it's important that we first gain an understanding of what their objectives are and the requirements of each of these objectives carry. This chart is an oversimplification of the process, but is intended to help us visualize the decision and what information we should be gathering or providing. For instance, if a landowner is tired of producing crops on ground where they regularly fail due to hydrology and is primarily wanting to walk away, then determining if the most passive form of restoration is feasible would be key. That is the track you see here over on the left-hand side. Passive would include essentially just walking away and makes the most sense in areas such as floodplains, where we probably don't have a lot of drainage systems, and overbank flooding from the river or stream is what is leading to the wetland system. It is important, though, that even if that is what the landowner wants, that we're also looking at what is the existing vegetation there. Will there be a seed source to colonize the area? Is there a predominance of invasive species that could be problematic? So while often natural regeneration is a desirable approach, it may not be feasible or may not get us to a desired end game. If there is drainage or a lack of desirable vegetation, then the next step up in intensity would be that second light blue column, but like a minimally active approach, which could include tree planting or just drainage removal. Tree plantings require active management in the first few years, but are generally low maintenance once established. And once you've removed tile drainage or filled a ditch, there's not a lot of maintenance to do afterwards. So these would be good options for a landowner who's really just wanting that walk-away approach. But if a landowner is interested in something more specific, say waterfowl hunting, or that second column, the site must be reviewed even more thoroughly. Will water be available at the right time of year to attract the birds? Will it be deep enough and not too deep to allow the birds to forage? Can the species access their food source? Is there thermal cover? Nesting cover in spring if that's a target. What would be the impact of any enhanced hydrology on the existing vegetation? Some landowners have requested to flood forested areas, but that is a detriment to the trees. For other landowners and our partners and conservation groups, ecological restoration is the goal. Diverse habitats that will support a variety of species, diversity of vegetation. These groups are looking not only at the large macro topographic scale, the return of elevations measured in feet, but also at the microtopographic level, changes in elevation measured in inches. In wetlands, even an inch in elevation change can have a dramatic impact on the vegetation community. Whether targeted species or entire ecosystems, both of these types of efforts will require collaborating with engineering teams, soil scientists, as well as biologists and the cultural resource experts to determine feasibility. And finally, I added a column on the far right dedicated to public management. These are the sites that will allow public access and are maintained or staffed by groups or agencies. These sites may involve more complex engineering, more moving parts that require extensive O&M. You're likely to hear over these next two sessions that we do not recommend these complex active systems to individual landowners. Moving parts require too much maintenance and too high risk of failure. But when personnel are available and structures such as stop log structures, flap gates, and larger embankments can achieve the wetland restoration goals, they may be feasible and provide managers with more options of different types of management. So breaking this down a little more into the three major components that we'll be talking about over these next 2 weeks, how these biology, soils, and engineering really play a role in determining these. This visualization hopefully shows that there's linkages between all of these and all the different talks you're going to hear over the course of these 2 sessions. Each of these 3 categories cross all the different tracks shown in the last slide and require an examination by everyone you're hearing on these calls in the next 2 weeks. For hydrology, as a biologist, I would be looking at the depth, timing, and duration of water and how that supports the wetland community. And each of these factors is influenced by the soils that are on site. Is it clay? How deep? Is it underlain with gravel? And from an engineering, what elevations are present? Has the site been leveled? Is there drainage? Impacts of off-site flooding and drainage. Let's not impact the neighbors. From vegetation, I'm going to look at where in the state the wetland is located, what wetlands are present in the area, and how would that impact diversity and vegetative types. Soils play a tremendous role in this. What is the drainage class, the ecological site description if available, tree suitability, and the soils impact engineering feasibility of macro and micro topography and the water level control. And finally, when we look at that long-term management, as a biologist, I would be looking at what those implications are, what types of disturbance are needed, invasive species control, water level management that impacts vegetation establishment, and soils must be considered as well. Disturbance types on soils such as muck can present difficulties. Fire on muck is a high risk and can only be done when the ground is saturated. So a disturbance regime necessary in that soil type needs careful consideration. And engineering design can be based on more passive and active systems. Again, this is an oversimplification of what's going on these sites. But hopefully this shows why all these disciplines are here for these next 2 weeks to show, how we would assess this to meet landowner objectives. Let's start with some snapshots from the biological perspective, not only the wildlife, but the human objectives in the wetland restoration. If you recall 3 slides back, sometimes the landowner is strictly interested in land retirement. It is difficult or infeasible to farm, costly to maintain the drainage, or maybe the landowner is looking to retire themselves. There could be any number of reasons, but one thing is clear, the landowner is not interested or is not capable of complex management, and so keeping it simple is key. A fully passive situation, the site is just begging to be a wetland. You know when you're out there that this is just wanting to be a wetland. The cessation of all agricultural practices will result in the natural revegetation of the wetland species. This is often the case in floodplains, as stated earlier, where drainage systems are not what's impacting the hydrology, but rather the flood patterns themselves. In a minimally active system, the removal or blocking of those drainage systems will restore the hydrology, and a tree planting, such as the one here, will revegetate the site and will offer a way to get hardwood species that may not come in on their own. After about 2 to 3 years post-planting, though, trees are pretty low maintenance, so are a good option for landowners not looking for a lot of management. But of course, as we all know, it's not just about ceasing agricultural production on the land. Often the interest is to attract wildlife and specifically waterfowl. The assumption many landowners, and until recently even us natural resource professionals carried, was that more water was more better. That the deeper the water, the more extensive the area of water, the better it was for wildlife, including ducks. But that simply is not the case. Depending on the species we are targeting, shallow wetlands are ideal. Let's take the case of the migratory dabbling duck. I'm going to zoom in here on two in particular, conducting the classic duck move, butts up in the air. And this is an important image for a very specific reason. When dabbling ducks dabble, they dunk their heads and they search for food. And for the most part, and I hope you all are appreciating my fine graphics here, they can only reach 12 to 15 inches below the surface. So while you will see them out in big open water, what they are really searching for and what they really need, particularly during migration, are places to forage and fuel. The more opportunities you offer them to forage invertebrates and seed from the wetland floor and submerged vegetation, the more energy reserves they can build to survive the cold and the migration as they head south, and the migration and prepare for breeding as they head north. And this idea pertains to other species as well. Migratory shorebirds and wading birds need very shallow water. Their leg length coupled with their bill lengths being a driver in where they will hang out in a wetland. So in reality, we want average depths of our wetlands not to exceed 18 inches, and for larger portions of it to be even more shallow. Often we will have areas that may be deeper during high water periods of the year, but even those should not exceed 3 to 5 feet. Much deeper, and you're getting into diving duck depths. That's a tongue twister. And many diving duck species are looking for larger bodies of water, not necessarily our wetlands. Think lakes and reservoirs. So we're really targeting, although there will be deep areas in wetlands we plan, we're really targeting this 18-inch or shallower and even up to that mud flat depths on site. And this goes beyond even the water birds. There are other reasons to avoid deep water. When water is consistently deep across the area, even in the hot, dry months, it will remain deep enough to support fish. Fish are not desirable in most wetland systems. They are voracious predators on amphibian larvae, or tadpoles, and have detrimental impact on an already declining amphibian population. So when the water depth is 5 feet or more, the oxygen levels often remain sufficient enough that fish can survive even in those hot summer months. But if we get that down to 3 feet or less, as the water dries up, even though a fish may get into this area during a flood event, there are cases, especially in big floods, where fish will move into these areas. When those water levels drop, oxygen levels decline, the fish are eliminated from the system. If they dry up completely, that is even better. And tadpoles, which can not only tolerate these lower oxygen levels, but are also likely to metamorphosize and begin breathing air around the time O2 levels drop in the water, have an increased survival when the fish are excluded from this area. So we see an increase in the frog, toad, and salamander production when these are isolated wetlands away from fish populations. Variability in depth, which can be characterized by both macro and micro topography, impacts vegetation. Macro topography is the relative large variability in elevation in the landscape. We're talking in feet rather than inches. But as I stated earlier, in these wetland systems, inches, even bumps and ripples in the soil can have a huge impact on what can grow there. Often deep permanent water excludes vegetation, while shallow or saturated areas support a wide range of species. And as water fluctuates throughout the year, whether naturally through the water table and evapotranspiration or human-driven with structures, it results in areas that dry up in succession. So each level, as the water recedes, supports a different vegetative community. So what's occurring up here in these shallow flats will be very different than what occurs in areas that remain more permanently flooded. And we know even these areas that may have water most years will dry up in a very hot, dry summer, and that creates a different type of vegetative habitat. All of these providing value to different species of wildlife. So when you look at this, you see that when we're here where the duck is, and hopefully this is visible on your screens as well, we've got a little pintail hiding in the cattails. Waterfowl really prefer a 50-50 balance of vegetative cover to water. They can swim around in there, they have cover from avian predators, there's a lot of invertebrates that are living on the vegetation, there's seed source, as we showed earlier, down on the floor. There's a lot of opportunity to forage there as well as get thermal and protection. Whereas marsh birds, which you can see are very difficult to see on the far right, there is a bittern, and then there's actually a sora on the very far right. They like dense cover. You are not going to see these guys out there. You might hear them. If you're lucky, you might flush one if you walk too close to it, but for the most part, they are so hidden in this vegetation where they forage that they need that dense vegetation cover to really be attracted to a site. Where conversely, shorebirds are going to be an area with little to no vegetation, and it's going to need to be short. They scan the distance for predators, and tall vegetation obscures their view. And thick thick mats of dead vegetation will also impede their ability to forage. So they are really going to avoid anything that looks like the right-hand side of your screen and are going to hang out where there's mud and they know what's coming for them. So in designing the wetland, these types of details and impacts should be considered. And it is also important to consider not only how deep the water is, but how steep the slope is to get to that deep or shallow water. In the early days of wetland work, it was not uncommon for embankments or potholes to be constructed with steep slopes. These were typical of other structures we did, but they do carry some hazards. In addition to erosion concerns, it can be difficult for wildlife, particularly small wildlife, to get out when all of the slopes are too steep. Turtles and ducklings can struggle to get to where they need to. On the other hand, they can also be very enticing for species such as this muskrat. Muskrat will enter their den under the water, and if they can quickly burrow up and out of the water into the embankment, that's their preferred place to den up. But once you get muskrat in there, then the water will start to eat away at it, and it can really begin to destroy the integrity of the embankment. It becomes costly with washouts and failures. So for the muskrat, that is the ideal situation because the entrance to their den is underwater, away from predators, and they can get up to dry, warm ground pretty quickly. On the other hand, a more shallow, gradual slope is conducive to those animals that need gradual access out and can discourage the muskrat, which cannot get to a location that gets its den out of the water. So that is a lot of details about the whys and the biology behind some of the things we're going to talk about in the next couple sections. Hopefully, this makes sense as to why we have gone away from the more water, more better, and why we have moved more and more away from really deep water and encourage these variety of habitats and some of the lower impact structures out on site.
Good morning, everyone. Good morning, invited guests and the Indiana Conservation Partnership employees. Thanks for attending today. I saw there was 80 people on. That's wonderful that there's so many folks interested in wetlands. I'm going to try to dive in through some wetland engineering. Hopefully you're all going to help accompany me on this journey into the unknown. Because seriously, there's no exact science to wetland engineering. It's something that's very tough to learn, really. The 18 years of experience I have at NRCS has kind of taught me a lot of what I know about wetlands in Indiana. This quote right here does an excellent job of kind of capturing some of the wetlands in Indiana. Usually it's marginal land that breeds marginal farming and marginal farmers. So I think that hits the point on the head right there about some of our ag lands that are really low quality, but they're still trying to be farmed. So the agenda today, quickly, I'm kind of broke it up into two sections because I like to get long-winded about different restoration goals and techniques. So hopefully cover a brief history and then talk a little bit about the teamwork, kind of like you're learning today. The agenda, so we'll just dive straight in. A lot of the wetlands that you're going to be designing in Indiana are not going to look like this. This is a wetland outside of Vigo County, close to the Wabash River. Excellent place for water and wildlife, really not a good place for cash crops. Year after year, this producer was losing a crop due to flooding, and finally he had enough sense to return it to its pre-disturbance conditions. But this isn't exactly what we're always going to see a lot of our restoration projects. Many of them may look like this, no water at all on them throughout the entire year. No problem. From an engineering perspective, this is a failed project in my mind because there is no water, but we need to set those perspectives aside and however, understand that there is beneficial to this in and around and the mat of vegetation that's here. I mean, there is water in this wetland project. You can't see it on the surface. So something to water isn't always good. So how did we get here? Kind of a brief history in Indiana. You know, Indiana used to have 5.6 million acres of wetlands, which is amazing. Unfortunately, today we only about 813,000 acres, or about 3.5% of the whole entire state. So it's unfortunate we've lost as many acres as we had. And how did we get there? This Drain the Swamp. This is a wonderful sign outside of the Limberlost Swamp in Adams and Jay County. It kind of showcases some of the techniques or the materials that some of our contractors have used to help drain the ground. And of course, the classic open ditch or open channel that cuts through the landscape is another one of the wonderful techniques we use to get that excessive runoff off the ground. The quicker the producer can dry up the landscape to plant, the better chances they are to have a higher yield and be profitable. But it's always not very economically feasible. So it's something to look at. So teamwork. I'd like to say that it would only take an engineer, but unfortunately it doesn't. It really takes a diverse background of people to restore a wetland, as you're learning today from the different disciplines that are here. One person I'd really like to highlight in this list in the teamwork is the landowner. They're the owner of the private lands that are willing to allow it to go back to its original landscape. So if it wasn't for them, we wouldn't be working. And many times that landowner is misguided in how they want to accomplish this goal. So as Bree mentioned earlier, we need to set realistic expectations to what the restoration work that we do. And a person not to be overlooked in this list at the very bottom there is the programs and the contracts. Money does drive a lot of our what we do, and keep this person in mind because some of the policies and the guidelines that are set from the programs or the contracts kind of really alter on how or where we can do some of this restoration work. All right, next slide. So I'm going to dive into some of the different techniques or different goals that a producer could potentially looking at on their private lands. The first question we need to ask ourselves is, what is the goal of this restoration project? As an engineer, I can accomplish anything. I can build the biggest embankment east of the Mississippi or the smallest subsurface drain modification south of the Canadian border. So there's really anything that we can accomplish on a project, but we really need to look at the restoration goals and think about some of the stuff that Bree mentioned earlier in her diagram on kind of relying on maybe doing nothing to just rely on the natural regeneration and light plantings, or to the highly manipulated public managed projects that have embankments and the such. Keep in mind, Bree mentioned it earlier, in our conservation standard, we have to provide conditions similar to the original or natural pre-disturbance conditions. So think of that when you are doing a restoration project, is really, should you be doing a creative enhancement, or should we just be doing a restoration project? These goals are kind of in order of cost and maintenance. So without further ado, we'll just dive into the first one. So next slide. The first is really to do nothing. This is one of the easiest restoration techniques, is just seesaw farming. Let the landscape go back to its original state. Sometimes this is sped up by enhanced vegetation plantings. So Bree is going to do an excellent job next week kind of talking about some of those vegetative plantings in these do nothing projects. All right, next. Subsurface drainage modification. So this is one of the near and the dear, the easiest restoration techniques that are out there. This is accomplished by merely just destroying that existing clay or plastic tile and removing it from the ground. It's very important to remember when this technique is used, you really do need to compact that trench where that tile was installed to destroy and prevent any groundwater movement along that old channel. It's amazing what, if you do turn a soil, which Dena is going to talk about here in a little bit, how water will want to continue to migrate down those paths. I can tell you though, I kind of feel bad when we do this, because you think of the money and the time that was spent to put in this subsurface drainage to try to farm those marginal grounds, that it's kind of sad to do, but you got to remind yourself that it was marginal ground and something that really probably shouldn't have been farmed in the first place. So next slide. How do you find where these tiles are at? One place is you go to the drainage dicks. You look around, try to find that outlet pipe. Is there a place where that drainage tile is coming out of the field? The picture on the right there is a ditch that had normally been covered, or this tile outlet had normally been covered with water, and you had never seen this outlet till it was droughty conditions, and then you finally exposed itself. Once we did finally remove this tile from this wetland, the wetland actually that wasn't holding water very well was all of a sudden very saturated. So very important to check for outlets for that tile. Next slide. Say you can't find that outlet. So what's the next technique that you can use? And the aerial photo does an amazing job of capturing. Be very careful that this method is highly dependent on the soils, the time of the year, the month this picture was taken, and of course the location across the state of Indiana it varies. So you can see the picture from 1998, kind of in the western part of the left-hand side of that picture. You can kind of see little pieces of drainage in that. And then the picture on the right, on the east side of the field, which is, as you can tell, it was a different type of year, you can see even more of the drainage patterns that are in that field. So you might have to use multiple years to try to determine, is there subsurface drainage tiles out here on this landscape? Next slide. If you're lucky enough to have a drone, which some of us aren't, you might be able to witness the presence of the tile from 200 foot above the ground. As you can see in this photo here, there's some streaks that are running into this wetland, which are kind of telltale signs that there's tile on this project. You kind of ask yourself, well, this is a restored project and there's water in that little hole right there. So is that tile really having any issues? And I can tell you from experience, it does, unfortunately. Over time, yes, these tiles might be plugged or clogged, but they are still offering, unfortunately, a little bit of drainage on this project. One other thought in mind is if you run across this situation is you should consider maybe even daylighting these tiles if it's at all possible into this wetland to capture that subsurface water. Next slide. And then now we're looking at how, okay, you can't find it from the air, you can't find it from photos, so what other ways can you find that subsurface drainage? And water witching or dowsing is one of the techniques that when I was a young little engineer, they talked about. And I am actually, I don't know if I'm one of the given ones, but this technique actually does work for me. It's not 100% effective, but I just wanted to cover that if anyone ever says that they're water witching for that drainage tile, you understand what it is. And then the last technique to find that is trenching. Trenching is really a very effective way. It's very costly to do trenching. I would like to highlight though is try to increase your depth of trenching in the low-lying areas. It's amazing how years and years of sediment deposits have kind of filled in and make those tiles very deep that you can't easily hit them from 3 foot of cut. So when you are trenching, it really is important to go deep on it. And then from an engineering perspective is and going back to the contracting side of things, it's really good to talk about this trenching in a per footage standpoint. It's by the hour it's tough to determine, but it's always good to kind of cover that by foot. One thing you do is when you do hit that tile, all this is doing is trying to find if you're going to hit something below the ground. Is if you do hit that tile and that trencher brings up pieces of clay or pieces of plastic, is then you got to do your homework, unfortunately. Is that tile that you've hit providing drainage to a neighbor? Is it providing no drainage at all? Is it full of dirt? You have to really do your homework once you do hit those tiles. So it's very important to do that homework. And then lastly, can't be overlooked is it's very, very important to do your underground locates on any trenching project along the edge of a field. Is we don't want to find a fiber optic line. Those are very expensive to hit. And worst off is if you hit a gas line. Those are very deadly. So it's very important to have underground locates done in trenching.
Hey,
Next
Scott.
slide. Yes.
Got a question.
Sure.
Would capping the tile be an option instead of removing it?
Capping the tile, yeah. I'm going to cover that here in a second about ditch removal. The bad thing about capping the tile is there's potential, I'm assuming it's potentially a perforated tube, is the water will still be wanting to be pushed out of the perforations from the head upstream of that tile. So really removal of that tile for 50 foot, which I'm going to cover here in a second, is really the minimum, depending on the soil type that's there, to stop that tile flow. Is there others?
No, the other stuff is about water witching, and we're going to leave that alone.
Yeah, good deal. All right, next slide, Bree. So of course, when you're doing a subsurface, sometimes you can't always find the tile. This picture on the left right here was from a macro, which I'm going to talk about in a second, excavation. We had no idea the tile went through this landscape, and all of a sudden we were digging, and look what we come across. I probably didn't do my homework to find this tile, or it wasn't very visual to find where it was at. When we do come across situations like this, or the other two pictures is a tile hole or another tile that kind of exposed itself over years, is we really need to take these tiles out. You think by just cutting it like we've done here on this left picture is good enough. Unfortunately, year after year, that sediment in that tile will be loosened because of the changes in the surface, that it could potentially open back up. So the recommendation would really be go downstream of where this tile's at and remove a section of it there so that it never will potentially open up. If you do come across a wetland site that you've restored and did an excellent job, and it should have water according to the soils and the site conditions, but it's just not holding water like it is maybe there is some undetected drainage like this. Picture on the right, these two pictures are from an old wetland sites that we thought we had removed everything, but several years later we find out, hey, there's some tile that showed up that we didn't capture. So really takes a lot of homework to find these if possible. All right, next slide. So in some cases we can't remove the tile because it's maybe draining a neighbor or some other drainage needs that it has. So we have to look at doing some unperforated tubing through the wetland site. What's very important is to go with watertight fittings. We can't let any water into this drainage tile through the wetland site. If at all possible, it'd be nice to try to daylight that tile, but it's not always possible with every site condition that's there. One important construction aspect about doing solid tile is providing adequate compaction along this tube, and also providing an anti-seep collar along this tube to prevent any water from migrating along this drainage tile. It's unfortunate. You put it in thinking, okay, this is going to prevent my wetland from draining, but you have all the loose soils around that tile where that water will still want to try to flow. And like I highlighted there, the anti-seep collar, you can kind of see from the picture there, is very important to have in throughout our wetland situation to keep that water from wanting to migrate through it. Next slide. So that was about subsurface. Now we're going to be looking at surface modification. So we have our elusive ditch that usually goes through a lot of our project sites or through our projects. A drainage ditch or open channel really needs to be modified if it's possible. There are easements or local regulations. I think the state of Indiana has a law prohibiting obstructions of mutual drains, so drains that do serve a purpose for more than just one landowner. So be very careful when you are doing these ditch modification projects that you're not going to be backing it up onto a neighbor or preventing the drainage from that neighbor. You'll see from this picture on the right, the little red arrow is this ditch plug that was installed here isn't the full depth of the ditch. So this ditch is still, is still providing some sort of drainage through the wetland or through the ditch site, but it's really severely slowed it down. Next slide. So then you look at, okay, we put the ditch plug in, it's working great, but now we have water flowing across it. So sometimes we need to look about putting some rock or some sort of stabilization material. I know rock is never best in a wetland, so you could be looking at a turf reinforcement mat or something, but this is the picture I had, so I'm going to highlight it. But you might need to definitely be concerned about some sort of stabilization on the outlet of those ditch plugs. Sometimes we have to kind of worry about both sides of the ditch plug. In a floodplain situation, flood water might back up in across the opposite direction the ditch is normally flowing and cause scour on the other end. So be very important to look at that. To design this, you'll really need to look at our grade stabilization conservation practice standard to look at how we adequately design this structure on the outlet and the inlet of these ditch plugs. Next slide. So now we get to the specifications, the best part of it all right here. This is straight out of our conservation practice standard, the Wetland Restoration. You can find this in our Field Office Tech Guide, Section 4. If you haven't been there, that's where you find it. But this kind of specifies the minimum lengths of the plugs. This is both subsurface and surface drainage modifications here. So you can see from the clay soils that are there, 50 foot is the minimum that we're recommending in our Field Office Tech Guide. I would like to highlight, if you do have a site that can take it better, it's always important to think about maybe adding that extra safety factor and increasing the length of that ditch plug to make sure it's going to stay there for long term. All right, next slide. So that was some of the ditch and subsurface modifications. Now I'm going to cover some of the excavation techniques that we have. I want to remind again that this method should only be utilized to recreate the historic pre-disturbance wetland features, or the caveat, to provide a source of materials for embankments, dikes, or ditch plugs. So really, we shouldn't be doing a lot of excavation unless we're trying to recreate that pre-disturbance that was there. As you can see this from this photo here, this is an area of the field that was an old slough. To farm it, they pushed it in, so they didn't have to drive through the slough, and it farmed it for many, many years. And to restore it, we just recreated that old slough that was in that field, and we kind of returned it to that historic, that pre-disturbance conditions that were there. Next slide. This excavation picture here is a little bit more creative in obtaining the soil. It's the elusive donut shape, so jelly donut shape maybe. And there's a nice little tree left undisturbed in the middle, because we do not want to cut trees down when we build these macros. The photo on the left was after it was built. The photo on the right was from a Google photo from not too long ago, and you can see that tree is still doing a good job today. We didn't interfere with its roots too much, but sometimes you might see some very creative excavation for that earth fill material. Next slide. Yes. So the macro topography and micro topography. You see, I can't even say it. That's why I normally refer to these just as macros or micros, leaving off that topography. The macro is usually typically excavation that's around 18 inches deep, as Bree mentioned earlier. And then the micro topography is typically about 6 inches or less deep. So you have the big mud flats, kind of as you see in that picture on the right side there. The water's not going to stay in the micros very long. They're going to dry up pretty quickly, but provide that enhanced habitat for meeting the restoration goals that are there. Next one. So here's some creative configurations. Macros can be very complex with these meanders or multiple depths. If you see from the circle there, this is a little macro that has 3 varying depths. So as the conditions dry up, you'll have different habitat benches, I guess, if you will, on it. So very, very complex. Next one. And one thing I really like to highlight is these macros don't really need to be left with a smooth grade. The picture here was from a macro construction utilizing this large pan, and as you can see, it left big old ruts. Well, it's a wetland, it's wet, no wonder he's going to leave ruts. So there's no reason to push these in with a dozer. Just leave them, as you can see in that lower right picture, there's a diverse habitat from the ruts that were left there with the dry mud flats. Now, from an engineering perspective, this is tough because I want to have a smooth bottom, but that is not needed in these macros. We need to leave these rough and let the nature take them back over. Next slide. So how do we think about macros? Biology technique number 7. It's been there many years, is in our Field Office Tech Guide, Section 1, if you want to do a deeper read into it. It does an excellent job of talking about macros and the benefits and different configurations, shapes, and sizes. This clip right here is straight out of it, and it kind of covers those 3 different depths. I do want to warn you, though. I mean, this looks amazing on this paper right here, but actually constructing something like this to match is sometimes very, very complicated. And I'm going to warn you, contractors don't like doing it and will definitely charge you to do it. So it's very costly. So keep that in mind when you're trying to do some of these very, very diverse shapes and configurations, because Yeah, and also we need to also look back at what is that landowner's objectives. Do they want to have something that's these 3 levels and very costly and expensive to build, or do they just want a little dugout for what is being the goal for the project? Next slide. All right, so when we build these macros to kind of mimic the pre-disturbance features, you got to do something with that excavated material. So these habitat mounds, or these spoil piles, like I like to refer them to, create and add the diversity to the habitat. And by far, they're the cheapest locations to get rid of that excavated material, is just right next to where you excavated it. You can see from that tech note number 7 there is the different configurations of where you could put the spoil. Their placement should not create flooding, I guess. They really should not be embankments. These are not structural measures. You can see, however, from picture number 4 right there, or figure 4, is we are holding back a little water from the placement of that macro. But this is not a structural macro. This water will be going around this macro. It'll be on both sides of it, more than likely around that, embankment. So keep that in mind when you are getting rid of this spoil, is to not try to impound too much water. And lastly, construction sites like these are really regulated by IDEM, which require vegetation establishment. So weed or fast-growing vegetation really needs to be established on all these earth-fill areas. And definitely we want to provide some sort of temporary cover on the ground, because we really don't want these habitat mounds washing right back into where we dug them out. So very important to have establishment on these. And you can see from the picture here that there is some wheat being established on the mounds around it. The wheat isn't in the macro itself, but it's on the mounds around it. So next slide. So talking about excavation, of course, we got to pull it back to our conservation practice standard to see where and what we can do with it. 8-to-1 is something that we try to mimic. Bree did an excellent job this morning talking about why we want to go 8-to-1 or flatter with it. So keep that in mind. We don't want these real steep excavation holes. We want to try to maintain our depth to 30 inches of excavation. We really do not want to do that for more than 25% of that area that's out there. All excavation that is done really needs to be 20 foot from any embankments. Again, to keep those little rodents away from it, and erosion as least as possible. And then lastly, the total depth in all of our wetland excavations really should not be greater than 60 inches of water depth. We're not trying to create fish ponds. If we want a fish pond, we would build a pond. Next slide. So dikes and embankments, some of the practices that's tough. So usually we're working with one landowner on one parcel of ground. That ground, for the most part, has been altered and made to farm better. To accomplish our restoration project, we may need to resort to these dikes or embankments to keep water off or on a neighbor, or to enhance the duration of flooding on a site to mimic the natural conditions that are there. This was the only picture I could find. All these pictures that are in my slides are all pictures I've taken, but I could not find a dike picture, an embankment picture for a wetland, because they're not normally used on a lot of wetland sites across Indiana, because a lot of reasons, which I'm going to cover here. Is the first one is definitely the maintenance, the upkeep, the high cost of construction. There's just so many negatives to embankments and dike construction in wetlands. Another one is our specs, our engineering specs that we have on it, or our conservation specs. Say, okay, we can't have more than 30 inches of excavation. Okay, we can't have any more depth than 60 inches of water. So that leaves us about, in some cases, 30 inches of embankment heights to work with. We need to follow the grade stabilization structure of the pond standard. So that gives us emergency spillway. That brings our embankment down to 24 inches. So we only have like a 2-foot embankment to deal with. So that's really not a lot of embankment to do a lot of ponding. And really, these embankments should only be the last resort to meet your project goals. There's just so many negatives that outweighs the positives for embankments. Next slide. So kind of put some specs on it. 6-to-1 on the front slope and 3-to-1 on the back slope is something that we try to maintain, and the back slope is kind of downstream. Cutoff trenches are very important. Our spec has 4 foot is required if the height of the embankment is 4 foot. I do highly recommend putting a core trench on all earth fill embankments to prevent any seepage through them. And then lastly is that 6-foot top width is really the minimum top width we want on these dikes, bigger if possible. Next. So talking about that core trench is this was a wetland site that they scraped off for the very shallow core trench, and a few days later we went out and there was crawfish holes in the cut. So you know that there is definitely going to be some issues on this embankment. We really need to go deeper with this core trench to prevent those burrows from effectively draining our wetland if we wanted to have water in it. So core trenches are very important. Next slide. So dikes and embankments in a floodplain, or worse yet, the floodway, as defined by the Indiana Department of Natural Resources, their Division of Water, have a very high opportunity of failure, as you can see in this picture. This picture was actually from a wetland site outside of Terre Haute. If you kind of see that power plant in the background is no longer there. Give you reference to where this is at. This embankment that was built did not have a proper spillway. The thought process on this project was, well, we're going to have enough water on our macro, the river's going to come up and we're just going to equalize and water's not going to flow over this. Well, in this situation, the Wabash River is flowing to the left, and we're thinking, oh, we're going to get overland water on the macro from the right side to the left, right? No, the backwater came through this site going to the left, depending on how this site situation was, and overflowed this embankment and washed it out. So failure. All right, next slide, please. So how do you know if you're in a floodplain? The Indiana DNR does an amazing job of maintaining this website right here. It's not the friendliest link there. You could easily find that by searching in a search engine. But it kind of covers some of where's the floodplain at? Very useful tools. There's 2 different types of tools that are available. The best available layer, which I probably can't really see the one that's there, and there's also the floodplain information portal. These tabs on this sheet or on this website are really good for finding out where that floodplain's at and what's the elevation of that floodplain. So it's also very important that when applying for regulatory permits that you have some of this information. So very important website to have. And we're going to discuss more about permitting next week at next week's training. Next slide. So don't get me wrong, not all dikes are bad. Just try to, but most of the time they aren't very good. So a lot of planning, a lot of design oversight, and you can't forget long-term maintenance is needed to make these embankments effective. You can see the picture here of this gentleman. He's got his hand on his hips. He's upset. Why is my embankment washing out? And then the picture on the right, I'm not even going to talk about that. That's an unfortunate situation on an embankment in a wetland site that occurred. That there's just so many times that these embankments don't last. So be very careful when we do specify an embankment. Next slide. So we're worried about overtopping. What about those little rodents? We cannot forget about the beavers, the muskrats, and the voles on our project. So hands down, the best dam builders aren't engineers, unfortunately. They're beavers. These animals can build and maintain an amazing embankment. I mean, it's amazing what these little creatures can do. It's going to put me out of a job. But no, keep these rodents in mind when you're thinking about doing an embankment project, because they are going to try to prevent or enhance, in some cases, your embankment that you have. So hopefully I've gotten you scared of embankments. So let's move on. So what type of structures, structural stuff other than embankments, will you see on a wetland project? This is one that you've often, if you've dealt with wetlands across Indiana, this is one that you've often seen. It's the inline water control structure. This structure is installed with an inlet and outlet pipe. It has little stop log boards in it that can be pulled or put in to manipulate the water level. A very effective structure. I mean, what's great about this is the beaver can't touch this. They can touch the inlet and outlet, but they can't touch the structure itself unless someone leaves the top open, like you can see in that picture there. But no, what's really neat, and with technology innovations with this inline water control structures, they are now offering an automated water control structure that's connected to a photo cell. So all that landowner has to do now is wake up in the morning, say, hey, I want to increase the water, and then go to the computer and go to the software and say, hey, put the logs in, and then that automated water control structure would drop those logs in and create that highly managed wetland. So really neat technology that these inline water control structures have. Next slide. So some of the design components of the inline water control structure I'm going to highlight here is the anti-seep collar. It's very important to have those downstream towards the outlet of the structure. We don't want water migrating along that tile and finding its own way to get out. Another thing that's very important is that concrete pad underneath that structure. If you're not putting this on undisturbed ground and you're putting it on earth-filled soils, you really need something to prevent the settling of that structure. These are typically pretty heavy structures, and they will settle over time and give you all kinds of issues. Another important aspect is the compaction of the soils around this structure. Really, they need to be done by hand and not construction equipment. This structure that's pictured here is very delicate. A small bump from that excavator or that backhoe could really destroy this structure and make it so you can't even touch those stop logs that are in it. But as you can see from that lower left picture, they do have results. It's amazing when you do stop water on a project site what they have. Next slide. One water control structure I like to not recommend against using is this type of water control structure. This structure, the water actually flows over the boards at the inlet to get in and then go out. So these are very, very labor intensive because of the management of the debris that could be floating up to them. So do not recommend these. Our little rodent friends really love to deal with these structures when they're on a wetland situation. So please try not to utilize these. Next slide. One thing that's often overlooked, and I'd like to highlight here, is these pipe anchors. If you have a pipe, outlet or inlet pipe, that's exposed to any sort of flooding, as you all know, plastic likes to float. And if it's submerged, that pipe is going to want to float out of the ground. So you need to anchor it down. So having some sort of a concrete base with a wire over that pipe will prevent that pipe from wanting to leave and really affect your wetland site. So very important to have these anchors if you're doing a pipe situation. And next slide. And this is kind of the last of the structural techniques I'm going to cover. There are other types, but in my career, these were the big ones that I've dealt with. And this is a behemoth of a structure, the sheet pile weir structure. This structure is very effective at plugging a drainage ditch. I mean, it does an amazing job. And this picture that you see here, it has stop logs in it, so you can even manipulate the water level in this control structure to enhance the wetland upstream. But as I like to really highlight is this is a very, very expensive structure. Not only is it expensive, it's tough to sometimes find a contractor willing to put in this small section of sheet pile. But it is a structure, and I'd just like to highlight it here, but it should be used as a last resort if there's no other structural or non-structural technique that you have. Next slide. All right, I'm going to finish up here talking about some structure maintenance. As you all know, structures that you do put in a wetland are going to require a lot of active management. If the structure is managed adequately, it could really assist with our goals. But many, many times, and unfortunately I see all the bad stuff, is they're not cared for. Maintenance has to be done. Or if maintenance is done, as the picture on the right-hand side, it could be detrimental to that structure. The bush hogger that found this stop log structure decided not to stop and ended up bush hogging through it. So I just can't promote enough that structures are very a last resort in a wetland situation. One other thing I could like to highlight from that center picture is that the buoyant forces of plastic, once again, is this structure is actually floating out of the ground because that pipe that it's connected to is floating. So be very careful with structures. Next slide. This is a overflow pipe from a wetland, actually northern Indiana, that I come across. Do you see anything wrong with it? This was in the middle of the large excavated area, so it's serving some sort of overflow. I'd say maybe those PVC pipe openings right there are an issue. What would you say, like 5 blades of grass maybe? We'd end up plugging it. Yeah, and then when the water does get to that top of that bar guard to come in, I really feel pity for that land manager that has to take his little rowboat out there and try to clean this off. So a lot of maintenance on this structure. Next one. This is a grade stabilization structure that was used for an outlet on a wetland. It's one of those pipe drop structures. You can see that wonderful little trash rack around it. Definitely keeping the dead woody debris out of it, but as you can see from the picture on the left, it's definitely not keeping the live woodies from growing in and around it. And then it turns out one of those little beavers can effectively maneuver through a cattle panel structure and plug it tight, like you can see the picture on the right hand side. So they're amazing little creatures. Next slide. So the takeaway on this maintenance is really try to minimize all the structural components that you have on a project. Is if they're not managed properly, they're not going to be very effective, and they will often lead to failure. Does the landowner have that resources to maintain? Thinking long term, are the grandkids of this landowner willing to maintain this site? Oftentimes that's not the case, unfortunately. Also, not to be overlooked is there program limitations to this to the project that you put in. Many programs kind of stipulate how and when a site is managed or when that managed can be performed. So keep that in mind. Any structure maintenance that we do on a wetland is going to have devastating effects on the ecological systems of that wetland site. So keep that in mind, that how and when the site is accessed is going to play a very vital role. And then the last and most critical is the cost. It's not cheap to unfortunately maintain a lot of these structural components, and many times our conservation programs don't do a lot to help us offset the cost of maintenance on these structures. And then to finish it up, one more slide there, Bree, is the unintended consequences. I'm just going to highlight one unintended consequence of a wetland restoration project. Is that's not oil right there. That was something that was thought that there was oil on this wetland, but this wetland site, we ended up putting a steep pile structure in the middle of the ditch. Upstream of here was an very old degraded wetland that had scoured from an erosion cut and wasn't effectively holding water anymore. So the plan was we put that sheet pile structure in there. We flooded all of that decades of decomposed vegetation, and all of it became buoyant. And a few days later, it all was transported downstream, and I've never seen a site that had black water coming through it. The good thing, though, is a few days later, the water was perfectly clear from the picture on the right. So you always run across unintended consequences, unfortunately, when you do a lot of these wetland projects that you had no envisions that they would happen.
This way.
Welcome back, everyone. We're going to go ahead and get started. We think we've got the soils portion loaded here. And so with that, I'm going to turn it over to Dena Anderson.
All right, thanks, Bree. Let's try this again, everybody. How's that? So, like I said, I'm here in the swamp in South Georgia, so things are a little dicey sometimes when it comes to signal. So this was my biggest fear, that all things would go sideways, but we'll make the best of it. And I think everybody's gotten a lot more flexible and understanding with some of the hurdles and challenges that it takes to have these kinds of trainings and meetings and all that happy stuff. So we'll push forward and see what we come up with. So just wanted to talk a little bit, like I said before, I am the resource soil scientist, and so digging in the dirt is my favorite thing to do. And yes, I said the word dirt, but that's okay with me. They're both 4-letter words, and that's, you know, as long as you understand the importance of soils/dirt, I don't care what you call it anymore. So some people get a little fluffy. I don't. I've gotten over that. So welcome. We're going to talk a little bit about all that. So next slide, please. So yeah, so how do, you know, soils evaluations and observations work as far as looking at wetlands? Well, you know, preferably we're going to have some place that has some really good potential, maybe is already wet, or at least has the ability to hold some of that water. So we're going to talk a little bit about those types of things today. So, you know, pretty much what kind of potential does our site have, and does the soils, are they suitable for that type of thing? We're going to talk a little bit about identifying those different types of properties that could be more conducive to wetland enhancement or restoration and things of that sort. Some of the information resources that you can evaluate pre and post site visits to those things, to kind of see if you even have a good chance of making this thing work. And then a little bit of the challenges and some of those potential solutions that we might run into along the way throughout the course of the presentation and the site evaluations and all the happy stuff that you find. So next slide, please. So first question, what does every wetland need? Well, click it again, Bree. See if my animations work. The water. We got to have some water or at least of some way of finding it, getting it, holding it on a site so that it will potentially be, you know, available to all of the vegetation and the critters and all that sort of thing that Bree mentioned earlier in the thing. Click a couple more times. So whether that might be groundwater, so at the shallow groundwater, or whether we have overland flow, whether that's being some sort of flooding or just regular sheet flow along the area, then you know, is there a way that we can retain that water as it's flowing across the landscape and hold it in place a little bit longer so that we can restore or enhance those wetland areas that may have been pre-manipulated back in the day because somebody thought they needed to grow corn on it. So next slide, please. So pretty much, you know, like anything else of all good structures of where you're going to go, is location is everything. Where are you at in the landscape? Are you in a place that has the highest potential for retaining that water? Whether that be some broad, shallow flats like we have in the southeast, or maybe the big, broad lake plains that we have down towards Evansville. Floodplains tend to be a lot of where we see a lot of our wetland enhancement and restoration things happening. So are you in a spot in that floodplain that's going to be the most likely to retain that water, preferably like old meander scars or channel cutoffs and things like that, or clear up against the bluff in the areas that we call the back swamps, which are so far away that some of that groundwater is maybe peeking out at the toe of the slope, kind of like you see in that bottom cartoon diagram that I created a long time ago. Is that water coming back to the surface as it works its way towards the channel and creating those back swamp areas. So where are you at? Is the areas that you're concerned with, are they the most likely the ones to have the best option of enhancing or restoring a wetland? The other one that you see is if you're up in the northern part of the state and you get into some of the glacial potholes. Those are some shallow historical wetlands that we've had along the way. They started out as big chunks of ice that got covered up with soil material and glacial materials. And then as the ice melted, it left a bowl-shaped area after the fact. So those tend to collect a lot of surface water, and they're probably some of the Oh, well, the wetlands that a lot of people have the visual in their mind that, this is what a wetland looks like. So, it's going to have ducks on it, and it's going to have cattails and things like that. So yeah, location is everything. So first of all, are you in a spot that you can have the best option of, creating or enhancing what's already there. Next slide. Like I said before, kind of where are you at in relationship to the rest of the world? Being a little bit familiar with the soil materials that you have in your work area. Are you in an area that has some pretty good high probability of some relatively easy wetland restorations or creations? Or are you in some more challenging areas, like if you were in the south part of the state where we don't have as much glacial influence? Some of the bedrock areas can be pretty poorly suited to wetland enhancement or creation. If you're down here in the Mitchell Plain where we have all the karst and the sinkholes and things, usually a tough spot to get the whole water. So, but if you're, up in the till plains and things like that, or especially along the river systems, you got a little bit better option and that sort of thing. So just a little bit about being familiar with what you got to work with and what its, potential is for, doing this thing that we want to do, or what our landowners are envisioning that they want to create and go through with. So, next slide. So where do you can find some of this information? Like I said, this can just be some of your background research, before you even go out to the site, and we'll go through some other sources. But one of the things, that is the easiest to deal with and find is what are the soils mapped out there? Are they on the hydric soil list to even start with? So there's a couple of different places that you can get this information. One of those being the Field Office Tech Guide under Section 2 of the soils information. So this just is a little chart that tells you that, this is what the soils are mapped. And the cool thing about it is it tells you what landform those are on. So here, this particular one is just saying that we're in a Bell Creek. It's a flooded soil. And then it happens to be on the back swamps of those floodplains. So like I mentioned before, those back swamps tend to be pretty wet. So that could be a good place to start looking for doing this type of enhancement or creation. Next slide. This is pretty much the same report out of a different format. This comes from the Web Soil Survey. Back in the day, we used to say that you wanted to get this information only from the Field Office Tech Guide, but from now that all of the information pulls from one big database in the sky, it doesn't really make that much difference where you get this list from. They're both pulling from the same database, and so either or are perfectly acceptable resources for doing some preliminary evaluation and that sort of thing. So once again, here's the Bell Creek soil. This is in Bartholomew County, and then you can also see that the hydric status for that soil is considered yes. So like I said, that's just some of the check boxes that we need to go through as we're going through the planning and the application aspects of things, is that this is some of those questions that are going to be asked as you're going through some of the paperwork aspect of doing these types of plans and that sort of thing. Next slide. One of our favorites. So this is the NRCS 7-day flood duration map. This has been a layer that's created through utilizing a lot of the flooding and stream gauge data that the USGS has put along a lot of the major river systems and drainage systems and things. Chris Ritz has kind of been the person that has created most of these, The good thing, the nice thing about these flood duration maps is if you make the red area in your flood duration maps, then regardless of what the soil map might say, these are considered to be hydric for program application. We have utilized these to justify the need for creating or enhancing wetland sites along the Wabash especially, but some of our other major river systems, because we figure if they are going to be flooded for at least that 7-day period, then they are considered hydric for our application. If you don't have it for your particular area that your participant is wanting to look into, you can ask Chris Ritz to do a more specific site on request. So I've had him do a few for me in the past, so that seems to work pretty well. Just to make that checkbox and go from there. It's going to be the nice thing about a site like this is that you're going to get a lot of this overland flow through the lower areas of the floodplain. So a little bit of manipulation on some of those, and you're going to be able to hold that water a little bit longer. So, you know, but like Scott said, these are a little bit, they can be a little bit dicey because you got water flowing at whatever structure or things that you have built both directions. So it's a little bit of push and pull. So it takes a little bit more consideration in the design of how we're going to hold this water a little bit longer so that all of our critters and vegetation can take advantage of it. Next slide, please. So just a little bit about physical soil properties. You know, once again, it's getting back to, you know, what are our soils like? Do we have good potential for, you know, being able to hold water here and have it available to our critters and all of our vegetation to regenerate and various things like that. So we're just going to talk about some of the various physical properties that, you know, you can kind of at least get an idea about, and then we can, you know, as the soil scientist comes out to look at the site too, then this is the information and things that we're going to be looking at. Next slide, please. So this is pretty much it. I think this has some animation, Bree. There you go. So if you weren't awake before now, you can go back to sleep. So this is just some humor into all of this, so we're not all that dry. So soil composition, go back to soils class 101. So what are soils made out of? So the majority of them are mineral for the most part, 25% of water and air, and then a little bit of organic matter. That 4% there is pretty exaggerated for most of Indiana, but we'll just go with it. So the main thing is that, you know, that air and water, that's going to be the stuff that kind of comes and goes. It's going to vary throughout the year, and it's just going to be, you know, depending on when you're there, then, you know, how much is going to be there. So those two are not static. So next slide, please. Soil horizonation, this is just a little bit of, you know, what are the different layers in the soil? You know, what are the types of things that you're going to be looking at when we start doing excavation? You know, for the overall depths of most of our wetland restoration creation type projects, we're not going to get much past the B or the subsoil, but most of it, so it's just your A, your topsoil area layers, which maybe if you're in the northern part, you do have some organics, which are your mucks and peats and things like that. Then our subsoil is our B horizons, and then our parent material, what the soils are formed from, whether that's bedrock, glacial till, outwash, those types of materials, then those are your C and R horizons. So we always try to say that it's a very simple system. It's easy as ABC, and you keep it so that even the engineers can understand. Next slide, please. Soil textures. This is, we have a couple of different ones that we utilize here. So soil textures, we have the USDA classification system. We're looking at the soil size, particle size separate. So that's basically your sand, silt, and clay. And everybody knows what sand feels like. It's gritty. Hopefully you've been to the beach, and if not, I highly suggest it. Silt feels like flour. It's very dull, very powdery feeling. And then clay is the sticky, ooey, modeling clay type of thing. So, and then as a soil scientist, when we do field evaluations, we're evaluating the percentages of all of those as we texture the soil. Next slide, please. So then, as I mentioned before, there are two different ones that we utilize in a lot of our construction activities. So we utilize the USDA, and then the engineering folks utilize the Unified Classification System. So that is just, it's a more simplified, larger grouping of soil materials, and they're looking at it from a perspective of, how well these soils can be manipulated. So the textural triangle that you see there has the USDA texture triangle in behind the blue, and I hope that you can see the blue unified overlaid that. So like I said, it's just a more general grouping of basically on how those soil size particles can be manipulated and those textures can be manipulated. So when we do the reports, we make sure that we include both of those things for submittal to the construction folks. Next slide, please. Texturing the soil. I like to put tools in my PowerPoints just so that you can go back and refer to these at some point in time. So, so this is just a real nice little flow chart that kind of just walks you through the system. And I've taken a ball of soil, getting it a little bit wet, and trying to make a ribbon out of it. So, and when you're doing that, you're just trying to evaluate how much clay is in that most particularly, and then the sand. So once you kind of evaluate those two particle size, then the silt is whatever falls out in between. So, so you're really just trying to decide how good and how long of a ribbon can I make with this particular ball of soil material. Next slide, please. There's just another little visual to kind of show you what some of the different textures might look like. If you've ever had and looked at the high school soil judging manual, this is where that diagram comes from. If anyone happens to, here's a totally off base tidbit. If anyone happens to know John Bowen, who was a T/2000 soil conservationist and soil scientist way back in the day, those are his hands. He's now a private consultant in Seymour. Next slide. So soil permeability, that's pretty directly related to the soil textures that we're going to find. Why do we care about soil permeability? Well, if we've got an area that we want to try to hold water, we want to try to keep it there as long as possible. So, hopefully we don't lose it all out the bottom through a really sandy site or something like that. Or do we have enough material above it that's going to hold, or we can at least manipulate to the point that it'll be able to hold that water and provide us those wetland benefits that we're wanting to try to achieve on the site. So I'm not going to go through these, but this, like I said, this is just a kind of a chart that shows you the direct relationship that the siltier, clayier the material is, the slower the permeability. So that's a lot of individual particle sizes that the water needs to try to move around or between. And so it just takes it's a long and strenuous process to get a lot of water through a really clayey soil. So next slide, please. Soil color. One of our favorites. I always like to say soils is pretty simple. It's all about the visual, the tactile. What does it feel like? What's it look like? Sometimes it's even so what does it sound like? So So it's just a matter, it's a very physical type of evaluation. So the big thing that we like to talk about when it comes to color is that it is the most useful and visually appealing aspect of how does water move through the soil profile, and how does we know what that's telling us. So pretty much it all boils down to how much oxygen and how much water is moving through that particular soil profile. Kind of goes back to that little diagram of you know, what makes up a soil. So we always know that there's pretty much one mineral in soil that's responsible for its color, and that mineral is iron. And I always tell folks, you know, it's like, well, what does iron have to be exposed to in order to turn red? It has to be exposed to oxygen. It has to oxidize or rust. So if you have a soil that has a lot of bright red colors in it, that's telling me that the oxygen is moving through that soil profile pretty readily, and those iron minerals are oxidizing at a pretty high rate. So on the flip side of that, if you have a soil that has a lot of the pore space that's filled with water that doesn't allow that oxygen to move through the profile nearly as easily, then that iron minerals tend to stay reduced or in their gray kind of natural state. So there's a lot of chemistry and biology tied in with that. But in a nutshell, that's pretty much what it boils down to. So if it's gray, it's not going to have a chance to rust. So it just stays in that ooey gooey gray kind of color. So if you got a site that has a lot of those gray colors in it, then your probability of having a decent wetland site is probably going to be pretty good. So color's everything. Next slide, please. I have to throw a couple of these in just because this is how we do it. But this is just the Munsell color chart, if you've ever seen the Munsell color book. And this is just how we kind of read the colors a little bit. But the main thing that we're concerned with is that those two columns and the 4 2s and higher, then those are our gray and wetness colors that you kind of see there in the yellow box. So and then that's just how to read that particular color. So the one that I got the arrow on is a 10YR. That's the hue of the page. And then 5/2 or 5/2 is the value in the chroma. So those two chroma colors are what tells us that we have some drainage issues on a particular site. Next slide, please. These are just a couple of other pages. These are the Gley pages that you might see in the Munsell color book. I always just refer to these as the bottom of the pond mud colors. So if you've got these kinds of really grays to greens or different types of bluish colors, then the site's probably been pretty historically wet in the past. So so that's usually a good indicator. I like to say that soils are a good historical indicator of what the pre-existing conditions were before we started manipulating and draining and things like that. Just because that once these colors kind of appear, they don't necessarily go away that easily. So if you're seeing these types of colors, then historically from development perspective, they are probably been pretty wet in the past. So that means you've probably got a really good chance of restoring or enhancing that back to its natural condition. So next slide, please. This is one I threw in this morning because I get this question a lot. The main thing is that texture versus drainage. People want to assume that all clayey soils are poorly drained and that all sandy soils are well drained, and that is not necessarily the case. It's all dependent on where the natural water table, the water tables are in these soils. So you can have well drained clays and you can have poorly drained sand. So just because we've got some textures conflicting with what, seems to make common sense, then you have to get back to evaluating the materials of the site. If you hear snoring in the background, it's the puppy that's sitting behind me. Next slide, please. A little bit about soil depth. This kind of gets down to, is there some layer in the soil or something that's going to hold that water table up? So in the northern part of the state, you have dense till, glacial till. Usually if we get into that material, you're golden. That's going to be some really good stuff. For the most part, for most of the depths that we're going to be putting these types of practices in, we're probably not going to end up getting that deep. Fragipans in the southern part of the state are another one that are really good at impeding water tables and perching those water tables up on top of them. Probably the big thing is, are we concerned to where's just the normal water table, or this, what you see here in this picture is like the seasonal high water table that you might see on a site. So this kind of just gives you a visual as to, if we were going to go in and start doing some macro work or micro work, that, we wouldn't have to excavate too awful far, and we would have a good water source from beneath to keep those things wet as long as they can. Bedrocks, usually in our wetland areas, the bedrock's usually not deep and shallow enough to cause any issues, but the different types, as I mentioned before, have varying degrees of feasibility. So as I mentioned, with the karst topography, with the solution diluted limestones in the south and the sinkhole area, those probably are going to be really challenging sites to get to hold and go from there. So, but this particular picture, this is some siltstone. This is normally some pretty good stuff to have underneath because it's really fine grained and doesn't let the water move through it too quickly. So it's pretty tight. Next slide, please. So just wanted to touch on structure a little bit. This is pretty much, if you dig up a shovel full of soil and you drop it on the ground, how does it break apart? Does it come apart in great big clumps or blocks? Does it fall apart like cottage cheese? Or is it a whole bunch of plates, like a bunch of pancakes stacked up on top of it? That's something that we're concerned with because, this diagram kind of shows you a little bit about how that water moves through it. What we're wanting to do is, can we manipulate this structure to the point of being able to slow that water down and hold it in place as long as possible. So, next slide, please. So this is kind of, that overall goal that we're trying to do. So, when I'm talking soil health, this is the thing we're trying to kill. And then in this particular application, then this is the thing that we're trying to achieve. So it all goes back to what's the ultimate goal for the site. On this one, we want to be able to slow that water down. We want to hold that water as long as we can in place and move on from there. Next slide, please. So I just always, this quote is always stuck in my mind from when I first started working in Delaware County back in the early 90s. This is something that a contractor, excavation contractor, told me a long time ago. And he always said that clay and sand is money in the hand. Now remember, this is a contractor. And that sand and clay is money thrown away. So that was always kind of his little mantra for whether a site, when it came to feasibility of having a high probability of making a good pond. That was kind of always what he said. So I always thought that's always kind of stuck in my mind. So next slide. So this is not the greatest of figures, but it's right straight out of the specs. So this is pretty much, when we talk about, doing our excavations and where we're going to go with that spoil, are we going to have enough material potentially, if we have some highly permeable material down below, a clay layer, you know, are we going to have enough of that clay material still there when we do the excavation, you know, for that dike embankment, macro work, whatever it is that we're doing? Are we still going to have enough material there to seal that sand layer off so that we're going to be able to hold that water in place as long as possible? So that's just some of the things that we look at from there. Keep in mind, things to keep in mind. Just some of the other soil resources we're going to run through real quick. You know, where do we find this information? This is just some of those sources. Next slide. The main one's the Web Soil Survey, and we're going to be able to just flip through that real quickly. So next slide. So this is just some of the things that you do. It just goes through all that. The main thing is that you have to specify an area of interest. You can view your soil maps. You can create thematic maps and evaluate soils data. And then you can actually build your own custom report for the area that you're interested in. Next slide. This is just the opening thing. Next slide. Like I said, there's multiple ways to evaluate and navigate to your area of interest. So there's whatever works best for you. One of the big things is that if you have an address, or you can put in, you can import area of interest or things that you may have created in other GIS applications. Next slide. Main thing is just kind of keeping an eye on all of the different tabs. There's lots of them to keep a lookout for. But once you define an area of interest, then that's when those green hash marks will come up. You want to go and click on your soil map tab at the top. And then that will bring you up the area that you were interested in. And then off to the side is the map unit legend. There is the name of the map units, and then their blue ones are hyperlinked. So if you click on one of those, next slide, then it will bring up this. So once again, it tells you a little bit about the description of the soil, where it's located at on the landscape, and then some of the basic properties and qualities. So you can see here that this is Bonnie and it's in back swamps, and that in the properties and qualities, it is poorly drained. So, and then it gives you some other information there that could have some potential positives for wetland creation. Next slide. This is just a couple of thematic maps that we can utilize and you can create. So this just happens to be pond reservoir areas. This kind of just gives you a visual on that. This is the property and qualities. This is just a different one for depth of water tables. And this is the report that goes along with that. And then once again, the Web Soil Survey report. Next slide. Soil Web, next slide. This is actually an app that you can download on your phone for utilization in the field. So it'll tell you and utilizes the GPS on your phone, tell you what the soils map and things are in the site. Next slide. Like I said, you can put it on your map, your smartphone, your tablet, your laptop, all of those types of things. So, and then there's multiple ways to utilize it too. Next slide. Like I said, and you can pinpoint areas on here, and then it will give you more of a visual of what the soil profile looks like. This is actually a WRP area just south of the Austin, Indiana. All right, next slide. That's fine. We're supposed to be done by 11, right? Google Earth Pro. This is just it's a free thing that you can download. It's just kind of another tool to evaluate soils, or at least from aerial imagery, in my opinion. Next slide. Like I said, the cool thing is that the time slider on here is that you can evaluate just the general use of the site, you know, from a historical perspective up till most recent. So this is, like I said, that's just the same site. Scott mentioned that he had the donut. This one has an eyeball in it, so off there to the right. So next slide. And you get all that, and then you get some tentative things. You know, you can contact your favorite local soil scientist to come out and do some in-depth soil evaluations and look at the site and give you a firm yes or a no. So next slide. So this is just a copy or just an example of what one of my soil reports looks like for what we were going to do for a WRE area a few years back. Next slide. That's just what the soil, what the map looks like with the evaluated points on top of the soil map for there. So next slide. So just to recap, you know, a little bit, it's all about location. You know, are you in a site that has the potential for doing all these things that, you know, our landowner is envisioning? And then soil materials, going back and looking at all those physical properties and are they suitable for impounding this water? And then just, you know, once again, you know, utilizing the web soil survey to do some preliminary evaluations, some web soil or some soil web information. You know, if you're out there on site, you want to know right now what's going on. And then just Google Earth Pro to kind of do some historical revision or review of the site and things like that. So next slide. And as always, if you have any questions, you can reach me, you can call me, email me, whatever works for you. So that is it. I'm sorry if I rushed through at the tail end.
Thank you, Dena. Stephen, do we have any questions in the chat?
None in the chat.
Oh, that's frightening.
We'll
That's
give
a really nice tree.
We'll give a few moments here. If you do have any questions for any of us, we do have a few more minutes left in the presentation today. But just a reminder, there is a part 2 next week. That's when we'll get into some of the management questions. We'll talk about the cultural resources concerns and the other environmental special evaluations that need to go on to make sure that we are staying within compliance, as well as the permitting issues and additional engineering. So there's a part 2 next week, and so we hope everyone can join us for that. There's a separate Zoom link. Please see the flyer for that. Again, you do not have to register.
We have one question, Dena. So what are your thoughts on the soil web app and its application?
I really like the soil web app. Just because it's like you can put it on your phone, and I think it's Android and iPhone. There's one for both applications. So I just like it because if I can be standing out on a site and say, I wonder what's going on out here, and I can just pull it up and I can tell it to go to the site, and it will use the GPS on the phone, and it'll zoom you right there, and it'll show you the soil lines and the different map units, and then you can evaluate those map units through the hyperlinks and things like that. So it's really good, just field application tool. So that's it was around for a while, and then it went away for a while, and now it's back. So I'm really glad that they did the revisions and things. And you can actually link it to the web soil survey information too, and so it's all pulling from the same information in the background. So
Okay, and another question: if a structure is not needed on a wetland restoration site, is it necessary to request a soil boring?
I think it's always a pretty good idea, especially if you're going to do any sort of excavation work, you know, even from macro or a micro topography type of excavation, just to ensure that you've got some materials there that are going to be conducive to those activities. sometimes it's always good. And, you know, if we can get out there and verify that we've got some hydric soils too, that definitely helps. But a lot of times if in our floodplain areas, we get some sandier materials, we want to make sure that we've got some material within the area there somewhere that we can utilize to do some of that macro or micro work to create those shallow pools and things like that. So never a bad idea. And we all like to get out. So it gives us an opportunity to get out and visit with you, and especially the landowners and things like that. So.
Yeah, and Dena, I'll add on too, is really looking at the goals of the restoration project too. Is we don't want to say, hey, you're gonna just cut that tile, it's gonna be wet like crazy out there.
Yeah. Yeah, we need to be able to evaluate those conditions. So yeah.
Yep.
It's nice to go out and do something that somebody wants. I get excited. Okay, so I do a lot of wetland determinations. So I get all excited when I get the request. It's like, oh, cool, somebody wants to make one and not rip one out.
Hopefully everyone knows how to reach us. You can email us at any time. We appreciate everyone's time today. Thank you for bearing with us through the technical difficulties. We'll hopefully have those kinks worked out by next week. But until then, I hope to see everyone, or at least see everyone's names again next week, and we'll continue the discussion into the next phases of wetland restoration. Thank you, everyone.